All right, so we are in lesson 14-2, Algebra 1. Today's date is Thursday, March 28th, 2019. Put it down, 3/28. Today we're on adding and subtracting day 2. We're now doing it with two variables. Let's come back here and talk about where we are in our unit guide. After, where are we? We're on quick 14. After today, we are halfway done. After today, we are halfway done because we have 2 more lessons than a test. That means Friday we do 14-3. We have that week off for spring break. We come back Monday for 14-4. Test on Tuesday. All right, so let's get through this. Teacher error? What's the error? Okay. So now let's do like terms with 2 variables. Yesterday we did like terms with 1 variable. Let's do some review. These were the same notes from yesterday, like terms. The terms that have the same what and the same what. Quiet raised hand. They have to have these 2 things in order to be like terms. Quiet raised hand, or just look at your notes from yesterday. Oh man, Cohen. Yeah, go for it.
Ow.
Go for it, Cohen. The same variable. And the same what? Gunner?
Number.
Not quite.
Exponent.
Exponent, there it is. So, let's come back here. Load. Let's go to Algebra 1. Let's go to Cohen, 50. Let's go to Gunner, 50. All right, both of you have your cards in. Thank you, thank you. I'm going to add one additional thing to this. Here we go. My additional thing is variables, plural. Add an S to variables. Are you guys ready to participate? Is that why your hands are up? You ready to go? All right, Monse, what are you going to say? Like terms, yep. So you are only allowed to add and subtract like terms. Didn't even get to ask it, and Monse's on it. Gunner was also on it. You can only add and subtract like terms, but that now looks different. I gave you a preview yesterday, and this is what we're doing today. Like terms now have variables, plural, which means my like terms could look like this. XY and XY. These are both like terms. They have to have the same variables with the same powers, the same exponent. Here's another one. I'll do this color-coded. So x squared, y cubed, and 3x squared, y cubed. These are also like terms because they both have an x squared. They both have a y cubed. And if you want to get really fancy-pantsy, you can do this too. I'm not going to be quizzing this because, again, this is what I would be quizzing you on if we had time to go more in depth. But x, or let's make an A. Let's change our letters. A, B, and B, A. These are technically like terms as well. So those were like terms as well. These are also like terms. And you might be saying, now hold on, Mr. Sindel. A, B, and B, A, those are not the same. They're in the wrong order. Well, let me ask you this. If I do 2 times 3, is that the same thing as 3 times 2? Yeah. It is the same, which means these are both the same. Whenever you're multiplying, it doesn't matter for the order. These are both equal to 6. Therefore, these are both equal to AB, or they're both equal to AB or BA. Generally, mathematicians write it in alphabetical order. So usually you won't see something that looks like BA because that's not alphabetically correct. It should go A, B, C, D, E, F, G. So it should go A and then B. That's why I always do X and then Y. If I'm doing alphabetical order, it goes X, Y, Z. That's generally why I write X before Y. Technically, if I wrote Y before X, that's still mathematically correct, but mathematicians generally don't do that. All right. So here's our new thing. It's not really new, but you should be doing this anyway. When adding and subtracting, what never changes? This is an error that some people made yesterday. We're not supposed to change that number. Go for it, Jenny. The what never changes? It's kind of a hard question because I haven't talked about this explicitly. Julian?
The exponent?
It is the exponent. Thank you, Julian. Julian's card is in. The exponent never, ever, ever changes when you're adding and subtracting, but it will change when we start multiplying tomorrow. But for today, because we're only adding and subtracting, the exponent will never change. That means the only thing that you do change is adding and subtracting the what? And this is a word from yesterday. Gunnar, go for it. It's the more specific name. What's that number out front of the variable called? Starts with a C. Constant is just when you have no variable. It starts with a C-O-E.
Coefficient, Andres helped me with that.
Coefficient, write it down.
Andres also helped me with that.
All right, Andres was helping. Gunnar got it right. And Gunnar reported the good behavior. Okay, so what I mean by this is let's look at 3x squared plus 7x squared. What I mean by this is the exponent and the variable, these x squareds do not change. When I add them together, I still get something x squared. The thing that changes is this number out front, the coefficient. The coefficient is the thing that gets added and subtracted, but these exponents and variables, they stay the same. All I have to do now is count how many of these x squareds do I have? Well, I have 3 x squareds. I have 3 apples, I guess if I were making a metaphor, and another 7 apples. X squared is just counting the number of things. I have a total of 10 apples, or 10 x squareds. That's how I always think about polynomials. I don't think about it as 3x squared. I'm always thinking about it as 3 of something. 3 shoes, 3 apples, 3 oranges, 3 of something. Give me a fist of 5. How well are you following the lesson so far? Fist of 5. How well are you following? I'm seeing mostly 5s, a few 4s, but mostly 5s. All right, thanks. All right, example 1. Oh man, 2 different letters, 2 different variables. Who wants to take a shot at it? Fernando, go for it.
Okay, so you add the like terms?
Yep, you're going to add like terms. Which are the like terms? Are 2x squared and 3y squared? They're both squared, right? So those are like terms?
No.
Oh, darn.
2x and negative 4x.
Yeah, these 2x squared. And, oh, I like how you said it. It's negative 4x. If you just said squared, it would have been perfect. The 2x squared and the negative 4x squared, that negative is included. Those are like terms. They combine to form what, Fernando?
Negative 2x squared.
Negative 2x squared is indeed correct. All right, now I have to add the other like terms. Are these things like terms? Is this and this?
Yes.
Are they like terms, Fernando? They are? Okay, so those are my other like terms. When I add 3y squared and 2y squared, Fernando, what do I get?
5y.
Yep, I get 5y squared. And there's it. There it is. There's our final answer. Box it. It's always about trying to find the same letters to the same power, the same exponent. Those things are the same. All right, so Fernando, 50 XP. We are on to example 2. This is the form that you will see in the homework. Example 1 is just getting us used to like terms with two different variables. Example 2 and example 3 are things that you will be seeing on the homework tonight. And again, if you are bored by this lesson, you've already completed example 2 and example 3 because you went ahead of me, you can do the homework. I have that out in front of you. Who's going to help me with example 2? It's very similar to our last problem where if you're adding, you don't have to worry about anything. You can just do something immediately to the parentheses and then do the next procedure. What am I going to do to example 2? I'm going to wait for 10 seconds and see how many hands I can get in 10 seconds. I got 1 hand. I got Jose's hand. I've got 2 hands. I got Fernando's hand. How many other hands can I get? How many other hands know how to do this? I got 3 hands. I got Sergio's hand. I got 4 hands. I got Cohen's hand. Any other hands? Any other hands? Last call on hands. Jose, go for it.
So combine negative 4ab and ab.
So negative 4ab and ab. All right. So I agree. Those are like terms because they both have an ab. Both of them are to the power of 1. Both of these are to the power of 1. So what happens when I add those? What do I get?
You get -3.
You do indeed get -3ab because there is that invisible 1 here. 1 minus 4 is -3. So far so good, Jose?
And then -3 power 2.
Yep. Does that combine with anything else?
No.
No. Nope. Okay, so -3a to the power 2. Do I have everything?
Plus 2b to the power 2.
Oh, and then I have this. I'm going to do this in a box. I'm just trying to do a different symbol for each of these terms. Circle, underline, box. I'm trying to make sure that we all understand that these are different terms. They're not like terms. So plus 2b squared. And can I do anything else? Nope, that's it. You're right. We are done. That's as far as I can go. Box it. Thank you, Jose. Yeah, sometimes there aren't any like terms. This -3a squared, there was nothing like this a squared, so I can't do anything. I just leave it as -3a squared. All right, we're on to example 3. This is the hardest type of question that I can ask when I ever ask you to add or subtract polynomials on the test. This is the hardest test question right here. If you know how to do it, you are ready for the hardest test question. How many people want to take a shot at this one? I got one hand. I got Fernando. I got 2 hands. I got Andres. 3 hands. Sergio. Oh, we got 3 hands. 3 hands. 4 hands, Jose. Andres, go for it.
Okay, so you would have to, since, no, you have to distribute the negative into all of them.
Ah, perfect. That's the first step. Distribute the negative. Tell me what to do.
Turn into a plus,
Plus.
and then -2y.
Okay.
And then plus 3x.
Okay.
And then minus x to the second power of y.
All right. You said that perfect. X to the second power of y. And then what?
And then you combine like terms. So 4xy to the second power plus 3xy to the second power. It's 6xy. I mean 7xy.
So 7
7xy
to the second power.
Right.
All right. So far, so good.
Uh,
What's another like term?
6x to the second power.
6x
Y,
squared.
and
Alright.
then the x, and then also the x to the second power y.
These are both the same. You're saying these are like terms?
Yeah.
Okay. Then how do those two combine?
So 6. So you minus 6x. I mean x to the second power y to 6x to the second power y,
Okay.
and you get 5x to the second power.
A
plus
positive
x.
5
Yeah.
x squared y. Okay.
And then minus 3x to the second power.
Yep. Does that combine with anything else?
No.
Okay. So minus 3x to the second power. Okay.
And you minus 2y to the second power too, since it doesn't come like there's no like term.
Yep. No like terms for the 2y squared. So just subtract that 2y squared minus 2y squared. All right. Am I done? Can I do anything else?
No.
I'm not done, or I
Oh, wait.
can't do anything else.
No.
That's the final answer? It is indeed the final answer. There it is. Box it. All right, thank you, Andres. That was a hard one, and you were able to do it. I think you're ready for the test. All right, fist of 5. How well did you follow example 1, 2, and 3? Oh, man. 4s and 5s, you guys are on it. All right. So I have some additional things to tell you. This is not that important, and it's one of those things I don't really test you on. But if you want to be like an official mathematician, you should know these things. So we've talked about degree before. If I have something like 3x squared, this has a degree of what? Quiet, raise hand. 3x squared is a degree what? What degree is 3x squared? Julian. It is a second degree term because it's to the power of 2. You just look at the power, right? This is a second degree term. Thank you, Julian. But the question now is, well, what degree is this thing? Because it has multiple powers. Is it maybe just a degree 4? Because 4 is the highest power? I don't know. What do you guys think? What would your guess be for that degree? 3x squared y z to the 4th. What degree would you guess that is? Is it the 4th degree? Maybe I add 2 and 4, the 6th degree? Maybe I add all of them, 7th degree? I don't know. What would you guess? Fernando, what's your guess? 4th degree? It's a good guess. Anyone else want to take a shot? Does anyone agree with Fernando that's a 4th degree term? And we don't know, so it's okay. The guess was wrong, but it was a good guess, so I'm still going to give you XP. Thank you, Fernando. The way that you count or that you determine degree with multiple variables is you add the powers. You add, or the exponents, I should say, the exponents. But you have to be careful because this y exponent isn't y to the 0, it's y to the 1. Yeah, Monty has it. Whenever it's not listed, you assume that there's an invisible 1 there. Thank you, Monty. So now I just add 2 plus 1 plus 4, and this is a degree, what? Quiet raised hand. Josie? It is a degree 7 term. This is a degree 7 term. This was a degree 2 term. All right, thank you, Josie. All right, the reason I'm talking about that is because I want to talk about standard form. Standard form is how most mathematicians write polynomials. So this is when the term with the what is written first, followed by terms with the next something something. I'm going to give this to us because I want to get through these notes. The term with the highest degree. Highest or biggest degree. And then the next immediate term is the next highest degree. So it kind of gets smaller and smaller and smaller until you're left with either a constant or nothing. So the highest degree, then smaller, 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 then you're done. Let's take a look at how you would write a polynomial in standard form. Here is a pretty difficult polynomial to write in standard form. I need to find the degree of each of these terms. Is there someone that can volunteer and tell me the degree of each and every single one of these terms? I have 1, 2, 3, 4, 5 terms here. I need to know the degree of each of them. Who wants to volunteer and tell me what they are? Cohen, go for it.
Y is degree of 1.
Yep.
3x power 2. Y is 3.
Degree 3, yep.
2.
Degree 2.
3.
And 4. There they are. These are the degrees. I'll write that over here on the side. This is the degree. The degree is equal to 1, then 3, then 2, then 3, then 4. So this rule for standard form says write the highest or the biggest degree first. Well, which of these was the biggest, then the next, then the next? This is a little bit challenging, but if you want to take a shot at it, you can get some more XP. Did I give Cohen his XP? I did not. Cohen, there's your XP. Who wants to take a shot at this one? This is our last problem before you write your summary. Last chance to get XP, last chance to get your card in. If you haven't got your card in, I want to see one hand, 2 hands. Jose, go for it.
So x to the 4th power.
Yep, that's the first one that I write. What's the next one?
Negative 8x to the 2nd power.
Negative 8xy to the 2nd power.
Negative 3x to the 2nd power. Y.
Yep, and I'll pause here. So you just wrote the 4th degree, the 3rd degree, and the 3rd degree. It does not matter which order these are in because they're both degree 3. I could have switched them. You still would have been writing it in standard form. All right, yeah, continue on. Plus 17y to the power of 2. Plus y. There it is. This is now written in standard form. These are interchangeable. You can switch if you want. That was a degree 2 term. That was our degree 1 term. Notice that it goes 4, 3, 3, 2, 1. It's in descending degree. All right, thank you, Jose. All right, Give me a fist of 5 for this entire lesson. How well did you understand this entire lesson? I see 4, 4, 5, 5, 5, 6. Or is that a 5?
So 4.5.
4.5. All right. Go ahead and write your summaries now.